Have you ever tried self-hosting a Next.js app and thought it should be easier? Well, you're not alone. Last week, Ethan and Austin presented at Render ATL, walking through the challenges they overcame in self-hosting Next.js. Today, they're here to share those insights. Without further ado, here's Ethan sharing the trials and tribulations of self-hosting Next.js.
So hi everyone. Once again, this talk is called Trials and Tribulations of Self-Hosting Next.js. My name is Ethan Arrowood. I'm a senior software engineer at Harper.
And I am Austin Akers, a developer experience engineer, also at Harper.
So real quick before we dive in, a quick overview of what Harper is. Harper is an all-in-one Node.js platform. We have full file system access, an embedded database, a networking middleware system, and application hosting support. We're built on top of Node.js, and so it operates within a single process, and we leverage worker threads for performance. We also use clustering and replication for production scaling. The whole platform works together to provide a high-performance, easy-to-use, enterprise-grade developer experience. You may have known us previously as HarperDB, and we've recently rebranded to just Harper. But you may still see the HarperDB floating around throughout, the slides, some of our technology, and even sometimes the t-shirts we're wearing.
Now, as for everyone here, you stated, we'll be talking about Next.js. And if you are unfamiliar with Next.js, just a brief overview. Next.js is a full stack React framework for building modern web applications. It uses common patterns that many of you may have heard of before, which is server-side rendering, static site generation, and client-side rendering to provide a flexible and powerful development experience. But Next.js is much more than just what it can create. The entire development experience from prototyping to production is what makes Next.js so powerful. Which leads us to something very interesting to state is that hosting Next.js is surprisingly difficult. What we've come to realize, holistically, our goal was not to just host Next.js apps, but to provide a holistic Next.js application development experience, which led us to really state that it's much more than just Next start. So we created a high-level framework to dictate what it means to support Next.js. First, we broke things down as develop, right? So the development experience. Then, what does it look like to build Next.js? Then next up, we also what does it mean to deploy Next.js? And finally, what about running it? So let's dive in.
Great. So the first aspect of our framework is develop. For us, this meant providing parity with Next's excellent developer experience. For most developers, the first part that they ever interact with is the next dev command. This encapsulates what we know as dev mode, and this is the core to Next.js's developer experience. It includes features such as hot module reloading, fast refresh, error overlays, and DevTools integrations. Today, we're going to focus on hot module reloading. This aspect is powered by WebSockets and was one of the more difficult parts to integrate into Harper. So as a brief overview of how hot module reloading works, we have three subsystems in play: the browser or the client, the dev server itself, as well as the file system. So using this flow diagram, it starts at the top. The dev server will watch the source files on the machine. Then, when the browser requests the page from the dev server, that dev server will respond with the page injected with HMR. Now, it's actually injected with all of the other DevTool features, but in particular, it has the hot module reloading script. When the browser renders the page, it will run that script, and a part of that will establish the WebSocket back to the dev server, which is where all of the hot module reloading happens. So within that WebSocket connection, if the dev server detects a file change, it'll send an update event to the browser, and the browser will go back requesting that update data. The dev server will send the update data, and the browser will re-render the page. So a little bit more detail, what is a WebSocket? WebSockets are what we call a full duplex communication between the client and the server. And this allows for real-time data exchange without the need for HTTP request polling. The request starts as a regular HTTP GET request. And then it includes these special upgrading connection headers, which is what gives it its name, an HTTP upgrade request. The response will reply with a 101 switching protocols, as well as including those same headers. And there may be additional WebSocket headers determining like for security purposes or other protocol information. But then once established, the connection remains completely open and it allows for continuous data exchange. The best way that I like to think about this is imagine that two people are on the phone. In order to make sense of a conversation, one person will speak and then the other, usually in some sort of call and response format. However, there's nothing stopping you when you're on the phone from just talking over each other constantly, yelling out different things. This is actually how WebSockets work. Systems can implement, a sort of call and response, or like, I'm going to send you an operation, you're going to do something, and you might send something back to me, and I might wait on either side for those responses. But in general, the connection is live, and either system can send messages at any time. So the systems that, when you implement WebSockets, are usually pretty robust. So remember Harper's architecture diagram? We have that highly extensible networking middleware system. And it's this system that allows us to hook into the request response lifecycle and do all the custom HTTP stuff for enabling WebSockets. So we have, starting out with, our socket middleware. This one actually isn't a middleware, but is more of just kind of a wrapper around the net.createServer method from Node.js. So it's pretty extensible. But these other three methods, HTTP, WS, and upgrade, those are all proper middlewares. You'll see that last argument, the next variable, next parameter, that is what allows you to kind of pass things along if your particular handler doesn't need to process anything. So the HTTP method works just like any other HTTP middleware. This is very similar to that of Express or Happy. I think in particular, the library is called MIDI that this kind of emulates. You pass the request along and you can just kind of return your response. And if you don't want to process the request in your handler method, you can then just call the next callback with that request parameter. WebSocket works the same way, but has some additional parameters, particular for an existing WebSocket connection. And then the method that we actually care about in our right now is upgrade. This upgrade method goes back to that HTTP upgrade request that we went over in the last slide. So we're particularly going to handle the path _next webpack HMR. And if it's not that one, we might just pass the arguments along to the next handler, the next upgrade handler. And the cool thing is sometimes you might want to still pass those arguments along for like observability or logging purposes. But as you'll come to see, it's important that we filter out exactly when it's the Next.js app asking for this WebSocket upgrade. And that brings us to the Next.js server API. So like we said from the beginning, supporting Next is a lot more than just Next Start. It isn't very well known, but you can actually have full programmatic control over your Next server. So it starts out pretty simple. You import Next from Next, and then you call that function, giving a path to the directory path of your application. And for the dev server purposes, you have to enable dev mode via that dev true. You have to await the app.prepare call, and then this makes two handlers available, the request and upgrade handlers. That upgrade handler is what we're going to focus on. So putting it all together now, you grab that upgrade handler from Next.js, and then you create that Harper middleware, that Harper upgrade middleware. Again, you filter by the request URL, and if it matches, you're going to pass along that raw underlying request, socket, and head arguments to the Next.js upgrade handler. After it finishes, we actually are going to continue to pass along those instances to the next callback here, again, for that observability and logging purposes, because you might want to know more information about what was included in that request. And obviously, if you don't match the Webpack HMR route, then just pass it along to the default or to the whatever the next middleware is in the system. And so now, since we're running Next within Harper, we did have to create our own CLI experience. It was quite simple, but importantly, it bootstraps Harper and ensures that the whole environment is set up correctly for the Next.js development experience. Like we started this section, the next dev command is what most developers use the first time they're running Next. So we thought that emulating that CLI experience was crucial to our overall support for Next.js.
And next in our framework is build. So the next step in our framework is to support building Next.js apps. This was where our CLI experience really started to take shape. Just like the next dev command, we created HarperDB Next.js build command that would run the Next.js build operation within the Harper process and then cleanly exit. Given that Harper is a single process, multi-threaded platform, we needed to ensure that the build process was isolated. Why build the same app multiple times on the same machine, right? Threads in Harper generally all do the same thing unless we specify otherwise. At the beginning, we created a custom file-based thread locking mechanism to ensure that only one thread would run the build process. The solution worked pretty well, and this flow diagram documents how it works. So, unlike serverless platforms that treat each build and deployment as an independent unit, Harper instances are long-running server full processes. We couldn't really provide the same ephemeral build experience without completely filling up our users' Harper instances with build artifacts. So instead, at least for now, we kept things simple. Builds can happen either locally or remotely, but they will always override what is currently running. And this leads us to the next step in our framework, deploy. Production Harper systems are often clustered and replicated across regions. This is a major performance and reliability feature of the platform. So, since we don't really fit into the regular serverless model of ephemeral deployments, we had to come up with a way to deploy applications without disrupting production. You really wouldn't want your entire database to be reset every time you deployed your web app, right? Integrating with our clustering and replication process, we utilize a rolling deployment system. And the best part is that this isn't even just unique to Next.js. The entire Harper platform uses this technique to distribute operations across the network. So, as you see here, given a new application deployment, it can be deployed to any one of the available clusters. And now, if you take a look here, you'll see that there are the above these, each cluster is a green bars. This is representing traffic. And whichever as you can see, whichever cluster is first will execute the build and deploy sequence. Then it essentially replicates it to the other nodes. So one node is down updating, it's building and deploying. The other ones are then, taking the load or whatnot. And as we go over here, as the deployment operation is replicated across the instances, production disruption is greatly minimized or actually non-existent. So once all the nodes receive the update, the operation completes and the application is fully deployed. And like we said, this isn't just for Next.js applications. Harper already had this replication and clustering system in place for other operations. So we were able to just leverage it to create a positive Next.js application deployment experience.
So finally, the app is built and deployed, and now it's time to run it. So no, we still aren't using Next Start. But just like we use the Next.js server API to handle WebSocket upgrades, we can also use it to run the application. So first, start by setting up the app instance, and then you're going to get the request handler and the routes information. You can see here in our code example that we're using the component path now to also get the routes manifest file. This will matter in the actual middleware. So here we're getting that request handler as well as the routes. And then we're going to hook this all together into Harper's server.http method. This match routes method is kind of make-believe in this instance, but the point is that it takes in that routes manifest file, compares it with the request URL, and if it matches, then you're going to delegate the handling to Next.js, and if not, just pass it along to the rest of Harper. So that was pretty much it for running Next.js on Harper. But the reality is that Next has many versions, and it takes a lot of time for users to migrate and upgrade. So it was imperative that we supported multiple versions of Next. And it turns out Next prefers the same version is used to run the app that is used to build it. So we're going to leverage Node.js's dynamic import system to load the right Next version based on the user's provided application. So this starts by using the create_require method from Node module. We're going to take that app or that like component path, as we call them in Harper, and we're going to pass that to the create_require. And now this app require is a reference to essentially that require method that we all know from the CJS land. With that, we're actually able to use a method that's require.resolve, and we pass it a dependency name. And Node.js will go and figure out the correct dependency path of Next in this instance via the package JSON and all of that. You could pass then this path, this string, to the dynamic import method. You have to await that because it is a promise. And now that next import is the package itself. So in the next line, we're going to extract either the default or just hopefully it's the reference itself to the function, and we're off to the races creating the next app programmatically. And so we probably sound like a broken record at this point, but Harper isn't your isolated serverless environment host. Thus, we always have had the ability to run multiple applications within the same process. And so this naturally led us to exploring support for Next.js multi-zone applications, also known as micro frontends. Now, this pattern has mixed feelings, but I can tell you firsthand that it's very popular for enterprise companies. Multi-zone is basically multiple separate Next.js apps, traditionally deployed across multiple hosts. As requests come in, they will be routed to the appropriate application through the use of Next.js's asset prefix and redirects configuration options. So, for example, as this request comes into host 1, if the path was actually /store, the host 1 would be responsible for redirecting that request to the known host 3, and then serving it via that asset prefix resolution. And subsequently, if somehow a request comes into host 2 or 3 based on certain server configurations, they'll know how to delegate those. And that's what is referred to as like a hard navigation, because it requires a lot of HTTP overhead. But since Harper can run all 3 of the apps simultaneously on the same server, we've been experimenting with custom routing solutions, that leverage our HTTP middleware. And that's where we can leverage the routes manifest, figure out what those prefixes are, as well as like what traditionally would be like a redirect. We can actually just try and handle all of the requests without ever having to conduct a redirect. And we do so, via that middleware system where we, check the first handler, then the second, then the third, until it's exhausted, and either a path matches or it doesn't. And so this ideally decreases the amount of hard navigation that has to happen, and makes the performance of apps of this architecture significantly better. However, there was one issue that we ran into that turned out to be a pretty difficult limitation. We've called this the working directory problem. And so it's most common during development, but it's also how a lot of hosts work. But the idea is that when you have a single process, you have a single working directory. That's just a fact. There's no ifs, ands, or buts about it. Well, with Next.js, when you're running your app from source, either like in development or as some hosts will, you will run that app from that working directory, from the source working directory. So it's usually these apps are run from their own working directory. If we think back to the diagram of where there's multiple hosts, each of the 3 multi-zone apps would be running from their own separate working directory, their own separate processes. And so that's never an issue in that way of hosting multi-zone Next apps. But with Harper, since we're single process, and so there's a single working directory, if any of those apps actually depend on that working directory, it causes an issue because we can't set the working directory to that application if you have to run 3 separate apps. It turns out that Next.js actually is just fine with this. When you use Next.js programmatically and you pass in that directory path to the app server method, it handles it just fine. It does everything based on that configuration. But some React dependencies are not so dynamic. And they are dependent on methods like process.cwd and pieces like that. Unfortunately, we don't really have a workaround here, but it is just generally avoidable with good application design and implementation.
Now, what's next? Da-doonch. I know, right? Really cheesy joke. It's all stored in my database. But yes, so what's next, right? For us, so we're looking to have routing improvements. So improving, HTTP middleware, multi-zone support, and more. We also are, custom cache handler. So it's not just an HTTP request. It's not just HTTP request caching, but also Next.js is like internal cache. So just as a quick, just a quick summary, Harper has caching baked in. We provide the high level HTTP request caching, but we want to improve and dig deeper by hooking into Next.js's internal cache system and integrate that with our embedded database. Our early experiments have shown this can lead to major performance improvement. Next as well too is that as much as we love Next.js is a great framework. We want to have abstractions for other frameworks, for Vue, Nuxt, Svelte, Astro, Solid, and honestly, many more. So we want to look at how can we exactly supercharge those other wonderful frameworks that we have in our ecosystem. So in summary, remember that this is the framework we came up with for supporting Next.js holistically. We wanted to not just run Next.js apps, but provide a full development experience. So you too can self-host Next.js, but it's more than just running Next Start. Thank you. If you have any questions, please reach out to us, connect with us on LinkedIn. It's a pleasure to be able to present. So,
Yeah, thank you, everyone.
Thank you.